Hi viewers, you are welcome. In this video, we want to solve for lim f of x as x tends to infinity in f of x equals x divided by x plus 1 everything raised to power x. Guys, so we will be solving this using two different methods. So at the end of this video, so we are going to see which method work best and fastest for you. So at least you can drop that in the comment section. All right, let's go with the first method. So let's say solution. So we have, let's say m1, right? So if we look at this, we can express x divided by x plus 1 as 1 minus 1 divided by x plus 1. All right. So from here, we will let our m equals to the denominators here, so which is x plus 1. All right. So then we are going to have our x to be equals m minus 1. Now, if x tends to infinity, then m also tends to infinity. So because of the relationship here, do you understand? So now let's express this lane m tends to infinity, right? So we've expressed x divided by x plus 1 as 1 minus 1 divided by m, right? X plus 1 equals m. So raised to power x. So what's our x? M minus 1. Do you get that? So now let's break this down. So remember that if you have a raised to power m minus 1, right? So from the law of indices, this is equals a raised to power m. Sorry, so m minus n. So a raised to power m divided by a raised to power n. All right. So therefore, we are going to have something like this. So if you have 1 minus 1 divided by m raised to power m minus 1. This is equals 1 minus 1 divided by m raised to power t divided by 1 minus 1 divided by m. All right. But here, if you have lim m tends to infinity, and we have 1 minus 1 divided by m raised to power m. Do you understand? So you know this is what exponential raised to power minus 1. Do you understand? So I made the only for this. So therefore, we are going to have lim m tends to infinity. All right. Upper bracket of 1 minus 1 divided by m raised to power m divided by 1 minus 1 divided by m. So I already told you that this is equals minus 1 and this is a constant. You understand? So that is 1. So meaning that we have this to be equals exponential inverse. So or we say lim m tends to infinity, then 1 minus 1 divided by m raised to power m divided by 1 minus 1 divided by m, so equals exponential raised to power minus 1, or you say it's simply 1 divided by exponential. All right. So however, so remember that we use x, right? So you can just declare that lim x tends to infinity. So that's what we are asked to find. All right. So which is, this is our f of x. So we are going to have 1 minus 1 divided by x divided by 1 minus 1 divided by x raised to power this raised to power x. This is exponential raised to power minus 1, or 1 divided by exponential. So this is our first method. So let's try the second method as well. So method 2. So method 2. So the second method, we will be introducing the logarithm and series expansion. So remember, what we have is f of x equals x divided by x plus 1 raised to power x. All right. Here, let's have like our capital letter L equals lim x tends to infinity, then x divided by x plus 1 raised to power x. So like here we have to introduce ln to both sides. If you introduce ln to both sides, we are going to have ln L equals ln x tends to infinity. Then we are going to have ln here, x divided by x plus 1 raised to power x. So this is equals ln x tends to infinity. Then this, from the property of ln, so this will come down. So we have x ln x divided by x plus 1. All right. So, but however, we should recall that if you have ln x divided by x plus 1, this is equals ln 1 minus 1 divided by x plus 1. All right. So now looking at this, all of this, considering the limit of this, let's consider only 1 divided by x plus 1. So for the expansion of this, for for very large numbers of x, we are considering this, we are going to have a number that is very, very approaching 0. So let's say h equals 1 divided by x plus 1. This tends to 0. All right. So this expression, like this, let's say this will be ln. Do you get that? Ln 1 minus h equals minus h square minus h raised to power 3. This will be 2, this will be 3. So this continues like that. So this is a constant formula, or you call it series of logarithm. So applying that to the above, we are going to have ln 1 minus 1 divided by x plus 1 equals minus 1 divided by x plus 1 minus 1 divided by 2, then x plus 1. This continues. Now let's multiply through by x. So if you multiply through by x, we are going to have x times ln x divided by x plus 1. All right. So equals minus x divided by x plus 1. All right. Then minus x divided by 2x plus 1 square. This continues, right? So now I want to single and tell you that this, if you consider this, the whole of this, the whole of this, we are going to have minus 1 divided by x plus 1, right? So then let's balance it up with this, x divided by 2x plus 1 square minus this continues. Going like this, we are going to look for a number that approach infinity. So all that becomes 0. And if all that becomes 0, so we are going to have this minus 1. If this becomes 0, this becomes 0. We are going to have this. So we have minus times 1, right? So which is minus 1. So therefore we have ln x lim x as x tends to infinity multiply by lim x x plus 1 equals minus 1. So therefore we have lim of L, so which introduce L equals minus 1, and this could be expressed as, right, exponential lim L equals s minus 1, right? So you know this will cancel out this. We have our L to be exponential minus 1, so which is 1 divided by exponential. So therefore our final answer for this will be lim of x divided by x plus 1 raised to power x as x tends to infinity. This is equals 1 divided by exponential. Guys, this is a financial. Thank you for watching. I hope you enjoyed this video. Can you like and leave a comment? And don't forget to share with your friends and network. Kindly subscribe to Mathematics for daily math tricks and exam shortcuts. And as well, brain share. See you in my next video. Bye.